So today we're going to talk about GenAI agents, right? As we kind of go through slides, a couple of slides I wanted to kind of cover. This is the conference's antitrust policy. I'm just going to pause here. I think it is the usual common sense items, right? Data policy, no market allocation, avoid prices, discussion prices, and so on and so forth. Next, I do want to thank the conference sponsors. This year, they are the Standard, Coherent, the Gunter Group, and POSIT. Thank you for making this happen. Right. A little bit about me. I'm Eddie Trivedi. I am based in Atlanta. I'm a senior director with WTW. I have been with the firm for a little more than 20 years. And in the last couple of years, I started dabbling with AI, perhaps like many of you, started with ChatGPT. It started getting interesting, and we as a firm started really focusing heavily on what you can do besides asking ChatGPT random questions. And we did a deep dive. We continue to invest a lot of resources and money to kind of see how we can use AI, especially agentic AI, to make things better for insurance companies. So based on the learnings that we have, I am going to talk about a few items. So here is the agenda for today, right? So everybody has heard of AI chatbots like ChatGPT. But today we're going to discuss AI agents, right? So this is the next stage or the next in the evolution of AI systems in the workplace. Uh, I will be talking about large language models, explain what AI agents are and highlight how they differ from a traditional chatbot. Okay? We're going to cover the key foundations that define an agent and then explore some interesting use cases in the realm or the area of documentation and actual financial model generation. Ah, so first things first, the history, right? AI as a concept is not new, right? In the scientific arena, it started around 1950s. It seems shocking, but yes, there's a long history of AI. However, the big push started coming in the 1990s when the machine learning emerged, right? This is where we started using statistical techniques to identify patterns and trends in data. Now, from there, deep learning developed in the field of machine learning, utilizing artificial neural networks to make predictions, right? Now, one thing you'll notice that the improvements as seen here kind of go in line with the improvements in the computer infrastructure that's available, right? Now, based on deep learning, we then saw the rise of generative AI. Right? So this is the new in thing, a collection of neural network models capable of creating new content, which is where the term generative comes from, right? Generative AI models can also produce video, audio, text, or code. The area we are particularly interested in for this session is going to be in text and code generation, which does involve LLMs or large language models. So these models hold a significant potential for tasks such as coding, generating and documenting code, debugging, testing, translating, and reviewing code, items which are very relevant to actuarial financial modeling. First, we start with a survey. So at WTW, we recently conducted a survey with our clients to find out which areas of their work they're currently using AI or are planning to use AI in the future. And the most common application was code writing and model generation. Many clients also expressed interest in AI to generate documentation and these model excel, particularly with text-based tasks. Additionally, there was interest in using AI for testing and to lesser extent, data cleansing. This to me is not surprising. The current AI technology is far advanced, I would say fairly mature at this point for helping out with things like code writing, and as you see in some of my examples, including documentation too. Okay. Okay, I have a few animations. I'm just going to go through the animations and then going to talk about the slide. All right. You've heard of AI chatbots in areas of your work, right? But how can we expect these chatbots to help power the next industrial revolution, right? to make a leap forward from being a helpful chatbot to becoming a full-fledged virtual colleague. And for that, we need AI agents. Throughout this presentation, I'm going to draw parallels between a sharp actuarial analyst and an AI agent. So before that, let's see what sets an AI agent apart from a regular chatbot. Right? So the key differences are in the ability to plan and perform multi-step complex tasks, right? Unlike chatbots, which typically respond to single prompts. So you type a prompt, you get an answer, you may ask something else to it, you get a response back. But all it's really doing is talking or giving some responses, right? AI agents can go beyond that. They can break down and execute a series of actions to accomplish a broader goal. They truly act as a virtual colleague or an actual assistant in our use cases. Another important discussion is the ability to use tools. And this is going to be key, as you'll see in the subsequent slides, which allow them to interact with the outside world. For example, querying databases, sending emails, or performing other automated tasks. Right? Finally, AI agents have memory, which enables them to learn from past interactions and improve over time. Some of the key, I guess, AI agent role examples that we have seen in the industry. So one of the key benefits of the AI agent paradigm is that it allows us to create agents that represent specific roles within an organization, right? Just as roles within an insurance company might be divided among underwriting, claims processing, customer service, and fraud analysis, we will eventually have AI agents tailored to each of these functions. So we are going in the route of specialist, right? So this is not a generic AI virtual colleague. You will have an AI agent focused on, let's say, being a developer or being a writer, and so on and so forth. These agents will not only handle their specialized tasks, but they will also interact with one another, delegating tasks and collaborating much like humans do within an organization. And we'll touch upon this topic in the subsequent slides as well. This approach offers a significant advantage. Instead of relying on one large monolithic agent to handle everything, right? We can develop smaller, more specialized agents that are easier to build, maintain, and optimize for specific tasks. Essentially, if you reduce the domain of expertise required for an AI agent, they actually do a much better job than a generic AI agent. So instead of focusing solely on theory, right, we thought it'd be useful to share two concrete examples of AI agents developed, right? So here you see a video which is just kind of scrolling through an example of model documentation for an actual cash flow model. This was developed by an AI agent. Uh, this system, or this AI agent system, can generate documentation for a cash flow model, any arbitrary cash flow model, and produce a good first draft of documentation, similar to what you might expect from a junior analyst. The way I try and describe that to colleagues as well, right, is the AI generated documentation is good. It can tell you what a model does, but it cannot tell you why the model does what it does. That aspect still has to be added by the human being. So AI agent is a tool which makes a modeler far more productive. The second example, this is a more complex task. This is long-form coding task. Here, the AI agent takes an entire Excel-based cash flow model and converts it into a fully coded cash flow model in a robust financial modeling system. In this case, this happens to be Risco TFM, a financial modeling system developed by WW. Right? Instead of translating the model column by column, the agent generates the entire solution holistically, providing a complete and integrated result. These are some brief snapshots. I'm going to go into more detail about the underpinnings of how these tools work in subsequent slides. Right. Now let's talk about agentic behavior, what it is and how we kind of identify that. Right. I have some animation. I'm just going to kind of quickly go through it. Right. So before we kind of go into the practical use cases I highlighted before, right? Let's just talk about this AI agents and agentic behavior, right? There isn't a single characteristic that defines an AI agent, but there are what you call five key foundations that really enable what we call agentic behavior, right? So these are prompt engineering, fine-tuning, retrieval augmented generation, or RAG for short, function calling, and AI agent frameworks. These components together give this AI systems the ability to plan, execute complex tasks, and interact effectively with their environment. So now let's go into more detail about what all these actually mean, right? Prompt engineering. Now let's just go through all the animation here, and then I'm going to talk about these items here. Prompt engineering, fancy word, but really what I'm trying to say is it's a process of designing prompts or providing the AI agent feedback to elicit the desired behavior from the AI model. Right? So there are several techniques and approaches used for this, ranging from simple to more advanced. Right? First, if you want the AI to behave in a specific way, give it clear and detailed instructions. Now think of the same analogy. Like you have a new junior analyst who's joined the team who has very limited experience and you want to assign a task. Well, what will you do? You wouldn't just tell the person like, hey, just get this thing done. You will go beyond that, saying, I want this done. These are the steps that you need to follow. Maybe you can check it prior work. So the instructions you give are going to be far more detailed than the instructions you'd give to a more seasoned analyst. We apply the same parallel to an AI agent too, right? Be explicit about provide comprehensive rules, right? Many issues that we see with AI agents, right, arise, or AI in general, arise when users don't give enough detail. No matter how intelligent an AI is, it cannot perform well with vague or insufficient instructions, right? And this, just as mentioned, just as a highly intelligent person would struggle to complete a task without clear guidance, so will an AI. When working with AI, keep the parallel of how will you treat or work with a junior analyst. And then if you have the mentality, you can really take advantage of AI. Another technique is what we call a few shot learning. This involves providing AI with explicit examples of the output you want. For instance, if you need the AI to write cash flow code in a specific format, just give some examples. Give it 3 or 4 examples. The AI is quite effective at learning from just a handful of examples, making it a powerful tool for guiding its output. This is the same parallel as what you have a junior analyst. You have a junior analyst and you wanted to do some work, for example, saying like, hey, can you update this document? It was done in the past. You can look at what was done last year. Right? In that case, what are you doing to a junior analyst? You're giving them examples of how it was done and trying to replicate the same process for this year. So that's the analogy I would give with few-shot learning. The third approach is self-reflection. Right? When you ask the AI to perform a task, right, its first attempt might be maybe around 80% accurate. However, if you then prompt it to reflect and improve its initial response, the revised version often comes closer to 90% or 95%. This simple technique can yield significant improvements with minimal effort. In real world, you have junior analysts, they do some work, you can just ask them to review it again and see if they can find any issues. Just self-review many times can just give an improvement results even with humans. The next thing I would say is chain of thought prompting. Right? This involves asking the AI to write out its reasoning process step by step. Right? For example, if you give it a math problem, you instruct it to show it's working, breaking the problem down into smaller logical steps. Right? This helps the AI move from A to B, B to C, and so on, significantly increasing accuracy by making each step more manageable. Right? However, with the latest generation of reasoning models, right, so these are like the O1, O3, Gemini Pro, reasoning is increasingly being built and baked in these AI models by default. So explicit instructions are often no longer necessary. But we again have a similar parallel uh, with a junior analyst. You ask them to do something, they're not sure, you can say, okay, tell me how are you going to approach this? and you try and ask him to break things down one step at a time, and you'll find that that process of breaking a complex item or job into small tasks makes it much more manageable, and it allows you to figure out which step has a small issue which you can then correct. The next technique for shaping model behavior is fine-tuning. So unlike prompt engineering, where you provide explicit instructions each time, fine-tuning actually embeds the desired behaviors directly into the model weights. But the model, I'm talking about the underlying AI model. Yeah. And here's how it typically works. You start with a pre-trained base model. The base model might be your generic model provided by a vendor such as GPT-4 or GPT-5 now, and create a fine-tuning dataset. So this dataset consists of ideal example queries, queries paired with the responses you want your model to generate, right? You're saying like, hey, model, this is the question I'm going to ask, and this is the response I get. So you're giving them examples and training the model to kind of change its underlying weights. Because all these models really have is a large number of weights to kind of give you the result you want, right? For example, right, if you want the AI to produce documentation in a specific style, you would compile around 100 examples of the style. You then run a fine-tuning process which adjusts the model's internal parameters so it's more likely to generate the outputs that match examples. This is a powerful way to customize the model's behavior, ensuring it consistently responds in the way you want. However, it is more involved process than prompt engineering, right? And typically requires additional data, because you give the examples of my query and response, and computational resources. Right? What essentially you're doing here is you're taking a generic AI model and making it a specialized domain-specific model by changing weights. This does require vast amount of resources, mainly data centers with lots of GPUs, something which I don't expect a typical insurance company to have capacity to it, but something which is done by the big tech companies. Next item is RAG, retrieval augmented generation. Fancy way of saying, optimize search. That's really what it is. This technique gives the AI the ability to access external data sources and incorporate that information in its responses. Right? Here's how it works. Imagine you have a large document, such as a lengthy set of policy terms and conditions, spanning several hundred pages. If you want to ask the AI a specific question, it's like, hey, what are the terms of the surrender values if a policyholder wants to surrender this policy, right? Just trying to figure out what the surrender charges are, applicable surrender charges are, and so on and so forth. The AI uses a process called embeddings to help find the answer. Now, embeddings are a high dimensional vectors that semantically represent pieces of text. Right? The document is first broken down into smaller chunks. For example, each page becomes an individual chunk. For each chunk, an embedding vector is created. When you submit your query, the system also generates embedding vectors for a question. The AI then compares the query's embedding vectors to those of all the document chunks. It identifies, let's say, the top 5 chunks whose vectors are most similar to the query. In effect, this acts like a Google search, retrieving the most relevant parts of the document. Okay. Once these top 5 relevant chunks are identified, the AI focuses on them rather than the entire document to generate its answer. This allows the AI to provide accurate, contextually relevant responses by grounding its answer in the most pertinent source material. At a high level, what it is really doing is you ask a query, it scans through all the documents in the semantic way, figures out which sections are the most relevant, and then it does a deeper dive on those sections and then gives you an answer back. So yeah, it really is a highly optimized search query. Function calling. I think this is one of my favorite items here for agentic AI behavior, and I think this is really important and adds a lot of value to agentic behavior. So we call this either tool use or function calling. This ability allows the AI to interact with external tools and systems, expanding its functionality far beyond simply answering questions. Right? For example, the AI might connect to databases or search engines to find and retrieve specific data. It could use calculation engines to perform complex data analysis or leverage tools like OpenAI's code interpreter to actually write and execute code, verifying its outputs in real time. Additionally, you can integrate custom applications. For instance, with our cash flow modeling system, RAFM, we can enable AI agents to run specific cash flow calculations, update data sources, or modify stress test configurations directly. Right? This capability transforms the AI from a passive expert, one that can only read or explain, into an active assistant that can actually perform tasks and automate processes on your behalf. I mean, in essence, tool use empowers AI agents to take action, making them truly useful collaborators in practical workflows. Taking a step back, what's really happening here is with access to APIs, you're telling the AI system, like, AI system, you don't need to be able to create your own database and search things. You have access to this wealth of information in this database, just query it. Right? So now you're basically giving an AI-based solution access to more data, more software solutions which you can leverage. Like in this example, I have Wolfram Alpha. If you ask an AI agent to do some calculations, it doesn't need to do it directly. It can just pass the query to Wolfram Alpha, right, which is a specialized tool, and we know it is accurate just based on history of it. Pass the query out to an expert, basically, get the output and get back to you. So it, in many ways, acts like a middle person, which is getting the query from you, figuring out, okay, based on this query's dimensions and the ask, whom can I reach out to get some help and get the answer? And this is really what I believe makes this agentic AI behavior so powerful. Last but not the least is what we call AI agent frameworks, that enable this kind of behavior. There are two main approaches here. One is called flow engineering, and the other is multi-agent systems. Right? Now, flow engineering. This involves breaking down a common task into a sequence of structured subtasks. Right? In my example here, uh, imagine you have a coding problem, right? You might have the AI first reflect on a problem, then design a solution approach, generate possible solutions, rank those solutions, create and run tasks, and finally select the best solution to return. This structured workflow helps ensure that each step is handled carefully, improving the reliability and quality of the AI's output. What we're doing is breaking down the query into smaller subtasks, which are a lot more manageable, are specialized, and you're going it in one step at a time. In the coding approach, you can say this is more like a waterfall-based approach too. Start with one step, then move on to the next one, and so on and so forth, till you get the final solution. The other approach, which I personally like more, and I think relief is more like a team tackling a problem, is a multi-agent system. So multi-agent systems, take a very modular approach by delegating different roles to a specialized sub-agents. Right? So instead of having one monolithic agent doing everything, you have a manager agent that orchestrates the process and delegates tasks. Now again, we'll draw parallels to a team of humans, like you have a project manager and you'll have folks with specific roles. By that, they really are specialized resources, right? So again, in this case, you have a coding workflow. The manager agent might assign code generation to an analyst agent, testing to a testing agent, and code review to a reviewer agent. If it was a team of humans, you had a project manager, you have a tester, you have a developer, you have a QA person, and you have a reviewer, right? So each of these sub-agents can use external tools, right? Again, going back to tool use of function calling, right? Such as databases or code interpreters to complete their specific tasks. the main advantage of this, modular multi-agent approach is that we are basically narrowing each agent's focus. This is again coming to specialization. Right? You can achieve higher accuracy and more specialized behavior. It also makes agent design more flexible and scalable, as you can easily add or modify specialized agents to suit new tasks or workflows. All right. So by combining all of these techniques, right, prompt engineering, fine-tuning, retrieval, augmented generation, tool use, and planning frameworks, right, we are able to achieve what we call agentic behavior, right? This enables AI systems to, frankly speaking, autonomously perform complex multi-stage tasks, moving beyond simple question answering to acting as capable virtual colleagues who can collaborate, problem solve, and execute tasks with minimal human intervention. We have basically created a virtual agent who is equivalent to a junior analyst, a sharp junior analyst. Now let's get to the fun part. What are some of the use cases? So at the start of the presentation, I showed you two short videos of examples. We're actually going to go into more details about how these were developed and give you some more details on how they can again be modified or improved upon. The first use case is documentation, right? So in this case, you have a cash flow model. In this case, it happens to be a C++ based model where you have different sections of the code, right? So imagine you have a cash flow model with around 400 columns of data, right? And if you give an AI agent all the code at once, it's going to get overwhelmed and the documentation is going to be quite superficial and not particularly useful, right? It is overwhelming the AI agent and it gives you, frankly speaking, junk. Now, instead of doing that, you take a more structured approach here, where with using this more structured approach, you get much better results. So what we did in the sample, right, is we started from the bottom and worked our way up. So what we did here is we gave it small chunks of code one at a time and say, document just this piece of code. In this example, I'm not sure how well you can see, this is a calculation for annuity payment guarantee, right? So what it does is, okay, it has access to the code interpreter and it creates what you call a natural language description just for this piece of code. So what it's doing is, if you're not familiar with C++ code, it is literally translating each line at a time to tell you what a calculation does in plain English, right? This is also called, very detailed pseudocode. It's clear, useful, and accurate. All right. Once it's done that, we then tell it to say like, hey, remember all the columns or the code sections that you documented? Can you now categorize all of these into suitable categories? So in this case, it would be things like, these are assumptions, these are the benefits or guarantees, these are expenses, right? So what we've done is documented each individual section of the code. Now we're asking the AI agent, go through all the documents that you created and start categorizing each of these document pieces. Okay? Once you do that, we are allocating the individual documentation to each of these categories that we have created. Right? So in this case, and once we have that, we say like, all the input variables you have, assign them to these each categories. For example, you might have a variable called init for initial commissions. This will get assigned to the commissions category. Fixed expense, A annual would be expenses, annuity guard would be guarantees, and so on and so forth. Now, once the documentation for each section and the various components of the model is complete, we then ask the AI to produce a high-level overview that summarizes the entire model documentation, right? This is sections. Now, this layered approach results in clear, organized, and comprehensive documentation. Now, there's one thing which I've been always asked, right? Is all of this stuff is automated. It's not that you require a user to go ahead and break the model up and pass it each section of code at a time. The AI tool actually does it all behind the scenes by itself. Other thing is this is a bottom to the top approach. Start with small sections of code, document them, get the AI to read through all the documentation, create the categories, assign the variables. Once it has all this middle level done, go and read through all of this stuff and produce a high level synopsis of what this documentation does. Okay, that's really what's happening behind the tool, all automated, and this becomes the end result of the solution. So this is the high level documentation. As you can see, it is overview. It talks about the conventions used in the model. Then we have at the bottom of the script video, we have the empty cash flows. So this is where we have the documentation for each, in this case, the variable name for the different ones in English. Right? It's going to go through and it's going to go through all the calculations going through. So this is just going through that. This expenses, this is another category of the model. And then we have survival probabilities for that. And again, the documentation is very good. Again, going back to it, it is the model can tell you what the calculation is being done, but not why. But it saves actuarial modelers a lot of time by leveraging AI to produce what you call the first draft of model documentation. And again, then the model has to add the why aspect to it. Okay. Okay. The second use case. The second use case is converting an Excel-based model to another financial system, in this case, RAFM or CDFM. Similar to the previous example, we are again breaking down a complex process into much more smaller and more manageable subproblems for the AI to handle. Right? Behind the scenes, what happens is we begin by extracting all the data and formulas from the Excel workbook. Next, we ask the AI to identify the columns in the workbook, specifically the column names and the formulas. So in this screenshot, you can see the column names would be like month, age, date, and month, age, date would be the headers for the formulas. Right? You can identify them one at a time. Once they are identified, again, we're categorizing them into different categories like commission, sum assured, expenses. Right? Once that's done, we then ask the AI to take all the identified formulas and create a hierarchy of dependencies. If you're familiar with it, again, Excel has this inspect dependency viewer, right? Saying this value uses what values for the calculation, so on and so forth. This is literally what the AI is doing. It's creating a hierarchy from the top to the bottom. Okay? One example in an actual workflow would be maybe the top value is the present value of all profits, which then requires present value of your expenses, present value of cash flows, and so on and so forth. We then also have the AI to distinguish between assumptions that are what we call variables and those that contain actual calculations, right? And those that serve as assumptions for lookups, like such as formulas such as index, match, VLOOKUP, and so on and so forth. This helps clarify the structure of the model and makes it much easier to take the Excel model, translate the formulas into another functional modeling systems language. In this case, it happens to be a C++. Right? So once all the steps are complete, we are then asking AI, can you generate the code, the Excel equivalent code into C++, for example? Okay, so we're doing a reverse. From Excel, we're going to a C++-based system here, and it has done all the translations for you. Again, this is being done one column at a time. Right? Once it's done, then again, we use function calling, or in this case, APIs, to inject user-generated code into the target system. And this is what it looks like. Right? So here we have an actual model with inputs. And this is a simple example, around 80 columns and about a dozen assumptions or so. This isn't a trivial model, but converting into manual, so laid back. If we had an actuary, we estimated this model would take a junior actuary about a week to convert from Excel to SQL. Using the AI agent system, we were able to reduce the time by 40%. So again, it wasn't 100% of the time, but it was 40%. So it made the junior modeler 40% more, I guess, more productive by using it. Uh, what's happening is that a lot of the manual effort of looking at Excel model, translating the Excel formulas into C++, which can be done manually, the first pass is done already. Once you have the model in a system, then you focus more on testing and validation and figuring out where the differences are, and then you are tweaking it. So this is the reason why the effort wasn't reduced by 100%, but it was reduced by 40%. Uh, and that really is, the end of my other example. Um, that's the end of my prepared slides. But what I wanted to say more towards it is that AI agents are a very useful tool to make you more productive in the work that you have to do. So it's not, I don't see AI agents as a replacement, but I see it more as a productive booster, another powerful tool in your tool set to get things done faster and not worry about some of the boring stuff of copying and pasting, doing translates manual. You are now focusing more on value added aspects in your actual career. Those are kind of like this is the end of my prepared slides. I'll just stop sharing. I'm happy to take any questions that this group has. If not, okay, Sharifa. If not, I can probably share some of the questions I generally get asked about AI agents. So I just want to kind of pause and see if there are any questions. I have the chat window open, so if you can add it. The question, I'll just repeat for everybody, is it may have made them 40% faster in their task, but did they learn 40% better? And the idea of being an analyst is that you do this task partly for the company and partly to learn, so you become better over time. There's always been that tension between good for the company versus good for analysts, but now they seem to be even more in conflict. Good question. Uh, I have received similar questions like, hey, if you're using AI agents, are we foregoing the learnings that are needed for a person to be more successful in the career, right? That really is comes down to that's the bottom line. The example I kind of give is if you look in the 80s and early 90s, the role, not role, a majority of the tasks that an actuary would do, right, were developing these commutation tables. I'm not sure how many of you still learn about commutation tables at this point, but I think these are all the PX, LX, your QX, all the tables of survivorship and all that done. And then these tables would be calculated by an actuary. Then you would have 2 or 3 junior actuaries who would calculate these tables. And that really was the job, the main part of the job. Then came computers. And along with computers came spreadsheets. Initially, it was Lotus Works and then Excel. And all the commutation tables could now be done very quickly by this Excel spreadsheets, right? And there was less of a need for actuaries to know the deep down, the big details about how this calculation, this tables are done. Did that result in actuaries losing the jobs or not learning the big, not having career opportunities? In fact, it was different. What changed is there was a change, but really what changed is the role and focus of actuaries changed. Because of the development of technology, right, instead of focusing on commutation table calculations, they start focusing more on building more complex products. And in effect, the field of actuaries grew tremendously from 80s and 90s. We now have far more actuaries than what we had in the 80s and 90s because of the advancements that are now possible because you have these tools. So my argument would be that yes, some of these basic items of translating code from Excel to C++ may be lost, but it's not that, oh, now I can't do that. Your focus will change in a different way. And I honestly believe that we will be focusing on more value add items and we will go through another massive change and growth in the field of actuaries. So hopefully, Rodan, that explains my view on that. Okay, thanks. All right. Are these AI agents part of RAFM, available to clients, or tools to boost consultants? Uh, so just one thing I want to clarify. AI agents, right? My question was AI agents was generic. AI agents can be developed by anyone. The examples I shared were tools that we have developed, right? Just to kind of give an example of how the AI agents are. Do we have AI agents as part of our solutions with clients? We have some. We have an AI assistant, which is embedded or included in Russell FM. We have also developed internal tools for helping clients with financial modeling. And we are heavily focused and investing on AI agents, and we are working on more AI agents for internal use as well as well as for sharing with clients, so for commercializations. All right. Do you know of any low-code, no-code software to tune, train an LLM to be used by members in a small company? The fine-tuning I mentioned in agentic AI is something that cannot be done with the financial resources of a small insurance company. So what we're talking about there, right, is taking a GPT, a generic AI solution developed, right? So GPT-4 or GPT-5, taking that and converting into a very specialized resource. That requires loads and loads of examples, and it requires a lot of GPUs and computational resources, something right now which is are only feasible or accessible to the big companies. You're talking about Microsoft, Google, Meta, and OpenAI as such. However, these tools are sold by these companies. So, for example, Microsoft has the OpenAI solutions, right? OpenAI models, which they sell to companies for a very low cost. So, if you are a Microsoft shop, you probably have access to Azure OpenAI models. Microsoft also has these what do you call specific agents. They're called research agent, for example, is one example, where they have already done the fine tuning, which you can leverage. So I don't think a small company has the resources to kind of fine tune an LLM model for these cases, but there are many out there that are available by companies to kind of leverage. So hopefully that explains or answers the question, Shastri. Okay. Um, all right. Next question is, have you seen examples where Python models being converted to WW Suite? Uh, so we have so we have examples of that. We've done some internal testing where you can do Python models and convert it. In the example I showed you, it was just Excel based, since Excel is a very common solution used for creating single cell testing models. So we can take that and just create a more robust model. So a lot of prototyping generally right now happens in Excel. Uh, we have talked to the developers who kind of develop our tools. I work very heavily with them. Um, the same approach can be used for with Python. There's nothing stopping it. We have not done that right now, but I think that's something that we can be done very easily. There's nothing special with Excel. You're just changing the front end from Excel to Python. It can be any other language. The tools right now available are very robust to make translations happen very seamlessly. Right? Uh, Great questions. Did I miss any questions here? Uh-huh. All right. Right. So I'll probably maybe share one question, which is okay. Yasin. Using technical documents, can it perform model change? Uh, so one example I can give about model changes. And this is where it also comes down to you know reviews and governance processes. So I think those are some things that we as actuaries need to be very mindful of. Uh, One example I can give you is in Draftone we have an AI assistant which helps clients or users internally as well to make model code changes. The Our current approach there is the AI assistant can tell you, will give you suggested code like, hey, this is the way you can make the change. But we do not allow the AI assistant to make the change directly in the system. We don't want to do that because again, in some cases, it does get it wrong, right? That's really why it's an AI assistant and not the model developer. And we want any responses or suggestions produced by an AI tool to be reviewed by a human being, agree that this makes sense, and then add it to a production or a dev version of the model. So that's really the approach that we have taken. No direct changes to the model, suggestions which can be reviewed and maybe modified by developer, and then add it to your modeling system. Hopefully that answers the question added here. No, some really great questions. You're fine, Rajiv. I'm happy to answer any of the questions we have. If not, okay, maybe one thing I'll ask. I think this is a question which comes up again and again with AI systems, and I do want to talk about it. I don't want to hide about it. The question that comes, which is true, is there's a concern with all AI systems that it is taking up or consuming a lot of energy, right? There are huge data centers being developed by these technology firms, and the question really is like, hey, there is a societal cost to all of the energy and resources being kind of spent on AI. How do you kind of reconcile with that? And I have to admit, my answer is I don't know. I still think that we're in early stages of the AI revolution, so to speak of, right? Uh, there are the realities that the energy usage is very high for development of the systems. There are very strong use cases of these AI agents making folks more productive. So again, there's an offset there. But also there's a lot of research being done by big firms like Microsoft and Google of how to make this AI searches far more energy efficient. So what I would say is I acknowledge that there's a lot of energy usage going on with this AI systems, but I firmly believe that that is something which is being looked at and considered by the global industry to tackle and then make sure that we have a better solution for that. Otherwise, we will see quite a few companies going bust. So just want to kind of share my thoughts. I think it's a common question I've been asked, and frankly, an important one for us to consider too. All right. I don't see any other questions, any other topics. If you have any other topics, feel free to reach out to me. I will add my email address in the chat in case there are any other follow-up questions. But again, happy to chat about AI anytime. I still think it's a promising tool. Again, it's important to keep it in perspective. AI is a tool, not a solution. I think that's a firm thing. It is not going to change. It's not going to do magic, but it's going to make you far more productive. With this mindset, AI is going to add value, a lot of value in our industry. So I think that's my personal view. Um, all right, I don't see any other questions. Aaron, maybe back to you if you want to conclude the session.
You're good. I think that's it. So thanks a lot, Eddie. Super interesting stuff. Much appreciated.
All right, great. Thank you, Aaron, and thank you, all attendees. I really appreciate you taking the time to listen to me. Okay.